This is Inside iOS Dev, show about real-world iOS development. This episode is part 2 of our series about refactoring a large initializer in Swift. You can find part 1 in the link in the show notes, and in this one we're extracting factories. Please leave a like and subscribe, and happy coding.
I think another idea is to use the factory builder pattern for this. What do you think, Alex?
Yeah, I mean, factory seems like a great option because look at that large um, initializer, right? And sort of, if we if we don't want to go for just the uh, um, default params in the initializer as to help with that, and maybe we have a more complex, because the issue with this is in this overly exaggerated and simplified example, this is fine and it works doing sort of this default initializations because they're simple, because each one of those objects doesn't have any dependencies of their own. But in real world application, all of these services will have their own dependencies, right? And it will be quite often contextual, right? What to inject there, and maybe some even param or another dependency like for services, it could be a HTTP client that you're injecting, or whatever else. So doing this will not gonna fly in the real world app, right? So instead, what Sandeep, what you were saying, the factory object design pattern is a great solution for this.
And also because it's not about just one-time initialization. So if you look in the initialization code, we, I mean the original initialization code, like it spanned like 14 or like 11 lines, right?
Mm-hmm.
To just initialize this customer object. So suppose if we want to use this customer object at multiple places, we will be supplying all these objects every time if we do not supply the default arguments, of course.
Right.
uh, and uh, and that's why this also drives me towards using the factory pattern. So yeah, let's start with it.
Mm-hmm.
So we are done with refactoring this customer initializer out and moving it to the factory. Now this customer factory is responsible for getting a customer as an output. So see, in the here we have to pass all these parameters to get the customer object. But now we can just make use of customer factory here and just ask the factory to get a customer for us. That's it.
Yeah,
We
and
don't need to pass the, yeah, the services and dependencies.
and now sort of throughout the code base, we can just either pass around the factory object or initialize a new factory object every time we want to produce a new consumer object, customer object, right?
Right.
So sort of, instead of calling what you were saying before, instead of calling this 11 lines of making writing this 11 lines of code, we're it's down to one or two, right?
Right. But I am still wondering, although we solve this problem, but we can't actually, if we want to change the dependency, one of those dependencies, how can we do that?
Right. All right. So with this factory object, we actually created two, and I'll walk you guys through it. The idea behind it is such: the responsibility of, so prior to the factory, what Sandeep was saying, the responsibility of constructing and assembling the object was actually uh, put on the user of this object was responsible for that, right? Whatever that place is in the code was responsible for assembling this customer object. Now we're creating a customer factory uh, object, which now takes on that role of the assembly, or aka factory of the customer, right? And what it does, it well utilizes its initializer, which is yes that large still, but it provides all of the services as needed, right? And in this case, again, in our very simplified example case, we're for now uh, initializing those objects right here in those variables, right? Computed properties, and it allows us to do this. So we have two down to two lines, instead of doing the whole assembly. But what this technique also gives us the ability to do is this, right? We can create another customer factory, where we can override one of those services and actually supply another implementation. So we have for the cart service, in the original we had the original cart implementation, but let's say for some reason somewhere else in the app we actually need a different customer object that with cart service behavior that's different, right? So this is what we can do. We can subclass it and then use that another different kind of factory for that use case to produce the same type of object, but the cart service injected will be different. This again, this example is kind of not mm, as illustrative as we hoped it would be, because this is a simplified example, right? That we have, and not real life code. Um, but yeah, so you get that benefit here.
So that's nice, Alex. Uh, so you are subclassing the customer factory so that you can pass another cart service implementation. So can't we do the same with customer, like subclassing the customer and then passing our own cart service in it?
So two things here. Technically, probably yes, but so let me kind of get you through explain the reasoning here. So there was a slight change that I forgot to mention that we did here was making all of those properties private, which you should be doing. So when you dependency injecting something, uh, most in most of the cases, likely all of those properties should be private, because that's the internal implementation of how are they stored, or are they passed in the initializer to something else, and that something else stores them, or whatever else, or they're used to just extract the values and that's it, and then discarded and not retained. That um, all of those facts and should not be exposed publicly as the interface of this object, right? They should be marked as private. That's sort of one important part here to note, which, for example, then means if you subclassing this customer object, you actually cannot override private properties. Swift does not allow you to do that, unfortunately. Um, Another reason, this is marked as final, right? So same, for some reason, in our code base, again, very simplified example out of any context, but for some reason we can't, we want to restrict subclassing. We just, you can't. This is it. It's a final type. Same would have been with structs. As far as I recall, structs cannot be, if it was a struct object, you cannot uh, subclass it, right?
Right,
So
we cannot subclass it. Yeah.
yeah, so same thing. You can't really do that. Um, and just in general, regardless of all of those scenarios, think about it conceptually. Why should you? Mm, why should you come up with a new type of of this object, new class, just so that you can, imagine these were uh, same way like here, not public and vars, right, that you can override. why should you be even creating a new type? For what reason? So that you just inject and use a different dependency in it. It does not make any sense. You're breeding so much code that's not kind of relevant and doesn't have any other behavior but injecting a new concrete instance of a generic abstract type.
That
You
makes a lot of sense to me,
y-
right?
you already are able to inject something else, right? That can of the same type, right? Assuming all of these are protocols, and that's sort of another thing to maybe talk a bit later. But realistically, all of these things that you're injecting should be a protocol. It doesn't matter if they're struct or class or however they've implemented, or actor. I guess that's the new thing in Swift. Don't matter, don't care. All of this is a protocol so that you can at runtime inject something else and do stuff like this, right? With another implementation of a thing that conforms and behaves uh, similarly, right? Or at least has the same API.
Yeah, but I think this approach, that like customer factory approach, I mean, it's quite good. You have followed this, but don't you think if I have to override another service, I would have to make another factory?
Potentially, yes. And we're going down the rabbit hole of dependency injection and mm, it kind of now spills into not only this concrete example of what do we do about this. It becomes a question of overall architecture and dependency injection approach and architecture throughout your code base, right? How do you tackle it holistically? Because we, you know, I acknowledge the fact, right, that we both acknowledge the fact that we're kicking the can here. We didn't really help as much with this at all with the original problem, right? We just kind of trying to resolve and push the decision making on what to instantiate and inject somewhere else, right? Out as much as we can. And we're kind of getting to the territory with this of okay, how we at least we encapsulated the assembly part, but now what do we do about this? How do we deal with this in dependencies and potentially maybe inject them too or assemble them as well somewhere else, right? And this is where you can do further refactoring and potentially um, maybe inject in this factory another factory that produces either all of these or some of them, right? We could break it apart into, let's say, login and sign up dependency or factory, right? That produces these two objects. Then we can have one factory for analytics because it seems like it's a standalone thing. Same with the book service, right? It doesn't seem like it's grouped with anything else. But for example, for financial service, checkout service, and cart service, we potentially could have a factory that makes all three of them because they're likely are similar and or sharing some dependencies of their own, right? And logic. And then music service and basketball service seem like also sort of different types which probably warrant their own factories potentially, right? And we can go on like this more and more and more, right? We potentially can do this. All right, guys. So what we're doing here to delegate uh, instantiation and initialization of some of the objects, and in this case, two, the login service and registration service, out of this factory to something else, we created this authentication service factory that we're actually injecting in this factory, right? And that's going to be the one producing those objects, potentially like default objects right now, but it could be overridden the same way like we did over here, and something else could be supplied, right? So we again kicked a can, portion of a can, if you will, up the chain to something else to make the decision making not in here, but somewhere else, and we're delegating, right? Just, I get what this object now states, this customer factory, that I rely on authentication service factory to function, inject it, and then in turn it will ask this factory to give the particular services needed, right? And we'll do exactly the same thing with this three, because they seem to be grouped together, and seems like potentially, maybe again in this overly simplified example, maybe they could go together and one factory can produce them, right? But what it will allow us to do, um, and then we can inject this um, object as well, sort of, but defer their initialization and creation to something else, somewhere else up the chain. All right, and then here, same thing, right? Um, we're stating that we're relying on this money services factory, which is injected now in the customer factory, and then again, same way, it supplies the concrete objects, concrete implementations of those: checkout service, card service, financial service. So this, and now this is how it will look like in our code base. The way we initialize this customer object. All right, so yeah, and now the way you initialize customers now is by, you still use customer factory for it, but it has dependencies now on those two assemblies, those two factories, right? And yeah, you just have to provide them. So it all kind of illustrates one thing, and again, unfortunately, it's a very small simplified example, but this is an illustration of how in your real world code base you would be, as you holistically approach dependency injection in your app, you try to push it out of here, right? Very down in the leaf, if you will, of your application, down in the tree of your app where you use this customer object. Instead of doing it all here, you push it outside and make this, defer the decision making up to whoever calls this. That's how we got to that, but this was not also the right place, so we decided, let's push this decision making on how to initialize these guys out of here to up to something else. That's how we came up with this factory uh, object. And then even in there, right, instead of making the decision here on initializing stuff, or even in the properties, right, we also want to push it out to somewhere else. And eventually, the point I'm trying to drive here and to make is that as you do it, you can do it in this waves and sequences, if you will, of your, deep inside of the your code, and then push it out. Eventually, the more you do that, eventually at some point you will come to the main function, where everything is assembled and put together in that one singular place of your app where the application actually starts. And from that point, you initialize all of your dependencies. And for iOS developers, that would be the app delegate, right? The did finish launching with options method, or I guess in the potentially in the scene delegate, one of the callbacks of the scene delegate now with a new way of doing it. But regardless, you can think of it as main function in quotes, right? And that's where you would do all of your assembly of all of your dependencies and initialize and instantiate everything. And those objects are then passed down through injection. And you actually, most of the time, will only have single object for each one of those things, like this single financial service. Because every time you would need it, you would probably use this money services factory, and um, you will have one single object shared everywhere for that service. That's not a singleton, right? Because that's another way of going about it. And you could have had a bunch of singletons. And that's technically a solution as well, but it's not scalable. And it's not, it will blow up in your face pretty quickly, and your code will be unmaintainable. This is more sane and maintainable, even though it looks like a lot of boilerplate right now because we just created so much stuff, right? Just so we work with this guy. And we ultimately didn't, technically, you would argue, didn't address any of this problem of, large initializer because it's still as large as it was in the beginning. But again, overly simplified example, um, kind of not how the real world application would go. This was it for this episode. Please leave a like and subscribe. Leave comments down below under the video, and I will see you next time.